Hello and welcome back to the Geo RGB community. The Triangulated Irregular Network interpolation, known as a team interpolation, is one of the most popular techniques to estimate numerical values in those places where we don't have samples or measurements. It is a very popular way of interpolation because its simplicity. What we are going to do today is a 3D surface where the coordinates x and y represents a two-dimensional plane and the set coordinates, that is the variable of interest, is the third dimension, and in this case is the zinc concentration. The surface is going to be created with three angles, and each vertex of these triangles are going to be the samples of the measurements. The values of the pixels inside each triangle are going to depend on the three closest vertices. This technique of interpolation is undervalued because currently there are a lot of softwares that can create very sophisticated interpolated maps just with a few clicks, like Kriging interpolation. However, in order to execute a proper Kriging interpolation, you have to do an exploratory data analysis, and it requires to have geostatistics knowledge. However, to apply team interpolation, you don't need to have a strong knowledge on geostatistics, and it provides really good results when the variable of interest is showing a gradient, and this gradient can be interpreted as a surface of first order. For example, in the estimation of the groundwater flow direction, the team interpolation is in most cases the best one. Also, if you don't have too much data, you can do the estimation manually because the simplicity of the team interpolation. Today, we are not going to see the mathematical part of this technique of interpolation. What we are going to learn is how to compute the team interpolation in QGIS. Okay, let's go to start. The goal for today is to create a map like this one, where we are going to deal with contaminated soils by zinc. Then what we want to know is how the contaminant is spread in this area. And to do that one, we are going to use the team interpolation. I already loaded the Muse River dataset on my session in QGIS, but if you don't know how to get this dataset, just go to the Geo RGB YouTube channel. Then here we have this lesson, the second lesson of the geostatistics course for beginners. And if you watch this tutorial, you are going to know how to get that dataset. But if you are interested in download that dataset directly, you can go to the Geo RGB community website at gscourse.online, then go to courses. And in this course, the geostatistics course for beginners, creating algorithm with R and QGIS, just click on this course, get enrolled, then start the course. Then in lesson 2, here you can download the file directly, okay? It's this file over here, data muse in format CSV. Also, if you watch this tutorial, you are going to know how to pass from the CSV file to a shape file, and that's the file that we have here, okay? If you click here, go properties, you are going to see here in information that we have a shape file. In this dataset, we have a lot of information. As you can see, we have the UTM coordinates and we have several metals over here, but for today we are going to be using the zinc concentration. This concentration is in ppm. There are other variables like elevation, distance to the river, and other parameters, but we are not going to use that ones today. The next step is to load the satellite imagery. We are going to use the Quick Map Services plugin. Then go to Google and here load the Google satellite image. If you don't know how to get this plugin, I mean the Quick Map Services plugin, just go to the Geo RGB YouTube channel, and here we have this tutorial over here where you are going to get a full explanation about how to install the plugin, how to use it, and also how to download satellite imagery with high resolution. Now the next step is to create interpolation. To do that one, just right here team, and it's going to be this one. If you cannot see the processing toolbox, just go here, processing, and click on toolbox, okay? Then we are going to use this algorithm, double click to open. For the vector layer, we are going to use the Muse River dataset. It's the only vector layer that we have here at the panel. Then for the interpolation attribute, is going to be the zinc concentration. Here in this option, what we want to select is the points. Then for the interpolation method, is going to be the linear one. For the extents, we are going to use this vectorial layer to establish the limits of the team interpolation. We are going to create a mask later because the team interpolation is going to cover a bigger extension, and we don't want to have a bigger extension. We are going to do the mask later. For the pixel size, the resolution that we want is 1 meter 1 by 1 meter. And here you can put any other numbers, but I believe 1 meter by 1 meter is good. Then here we are going to save the file. I created already a folder here at the desktop. Is this folder, and this one is going to be team. Save, and also we are going to save the triangulated interpolation. Then let's go to save here. Make sure you have selected the shape file, and here is going to be vector team. Then save, and let's go to run. The process is complete. We can close here. Now we are going to create a mask to remove all these areas from the team interpolation that they are out of the area of interest, okay? If we take this one out and we move this one to the top, the samples, you are going to see that for all this area we don't have any information. Then we want to remove all these areas from the team interpolation, okay? Then in order to do that one, what we are going to create, it's a new shapefile layer. Create a layer. It's going to be a new shapefile. Then here the name is going to be the perimeter. Let's go to save this one in this folder, and I'm going to put here limits because it's going to be the limits of the area. Then make sure you have a shapefile. Save, and here the geometry is going to be a polygon, and for the reference coordinate systems we are going to use the same as here, okay? The code is 28992, and that one is good, okay? And it doesn't change here. Okay, I'm going to repeat 28992 and select this one, and okay, now one is good. The name doesn't matter, and the rest of the parameters is good. Then press OK, and now we are going to edit. Then select the layer, press the pencil, and we are going to use the samples to create the limit. Then select this option, make zoom, and let's go to create it. Just selecting the points, we can join these points to create the mask, okay? Then I'm going to pass the video faster. Well, that's it. Then right click to finish, select a name. For the ID, I'm going to put number 1, and okay. And as you can see, for example, here we don't have information, but I decided to leave this area because it's like I'm going to finish the edition here. Save. Is part of the area, okay? This area is limited by the river, okay? Here we have a river, and that's the limit of this area. Then I decided to make this one a little bit more to the river, but not over here, because over here we don't have information in the team, okay? As you can see, this is the limit for the team, and also for this area, I decided to take the samples as the limit of the team also. That's it for the mask. Now let's go to cut the team interpolation. Then to do that one, go to raster. It's going to be extraction, clip raster by mask layer. Then the input layer is going to be the team. The mask is going to be the limits. This one we don't have to change anything, but we want to save the results. Okay, then select a folder. I'm going to save here, and this one is going to be the team cut. Save and run. The process is completed. Close, and we don't want to use this one more. Then we can take this one out or remove the layer directly. Okay, now let's go to see how we can change the symbology of the team interpolation. Then double click on the layer, go to symbology, and here what we want to select is the, but first, as you can see here, we have different limits. Okay, the minimum concentration is 113,428 and the maximum concentration is 1771. But if you check here at the attribute table, the minimum concentration is 113 and the maximum is 1839. Then we want to change that parameters. Then let's go here again, double click, and here select the single band pseudo color, and here I'm going to change the limits for 113 and for 1839. Then here I want to equal intervals, and I want 6 intervals. And I'm going to change the values here. 113 is good. This one is going to be 450. And then I'm going to add 350 for each of the next classes, but I'm going to pass very faster. And the last one is going to be 1839. Now what I'm going to do is change the colors. Double click to change the color. Go here. For this one I want a very intense red, like this one. Okay. For the next one is going to be also a red, but a little bit less intense. Okay. For this one is going to be a kind of purple, something like that. Okay. For the next one is going to be an orange. This one over here. Okay. For this one is going to be a yellow, something like that is good. Okay. Then we can apply at the moment to see how it looks like. And for the last one, for this one, we are going to apply a white color, but in this case we are going to apply a transparency over here or in opacity of 10%. Okay, and apply. That one is good. And now we are going to make some modifications on the color rendering. Then here for the blending mode, what we are going to select is overlight, and for the brightness we are going to put here -50, and for the contrast is going to be 50, and then apply. And we don't have any transparency here. Apply. That is because we have this layer here at the bottom. Then okay, take this one out, and now we have the transparency, and that's the result. Now what I'm going to do is modify the limits. I want a transparent color here, then go to symbology, select this one, and for the color is going to be transparent. Then the stroke color is going to be white, and the stroke width is going to be 0.5. Apply, and also I want this one a dash line, something like that could be better. Okay, and okay, and this one is the result. I'm going to take the samples to see better. And now I'm going to create the print layout composition. Then go to this option, press select a name. I'm going to put number 1. Okay. Click right on your mouse, then go to page properties, and I'm going to select this option. I want to see all the page, then I'm going to put here 70%. I'm going to select this option to bring the map at the map. I'm going to select all the page from here to here. The scale for this map is going to be 20,000. I'm going to put the image at the center with this option, more or less over here. And now what I'm going to do is add the legend here at the bottom. Then I'm going to select this option here to bring the legend over here. Now it's approximately because I have to make some additions. Then I'm going to remove some things from the legend. Select this option here, auto update. I'm going to take this one out, and I'm going to remove this one. And I'm going to remove this one also. And for the legend, I'm going to change this one. To do that one, just go here. I'm going to minimize this one. Double click on theme. Go to legend settings, and here I want to remove this one. Okay. Apply, and now I go here. Okay. And now I'm going to refresh, and now I have the legend, as you can see, in a different way. Then make this one bigger and put this one over here, and I'm going to modify these things. I'm going to change the name. This one is going to be the Muse River dataset. That one is good. Then this one is going to be the team interpolation. That one is good. And this one is going to be the zinc concentration in part per millions. That is going to be ppm. Now let's go to work on the formatting of the numbers. But first I would like to remove all the decimals, all for these zeros that I don't like. Then go here to team interpolation. Then here we are going to add 0 because we don't want any decimal. And apply. Okay, now we can go here, refresh this page, and now we have no decimals here. Okay, now let's double click here and add some information here. Then the first interval is going to be 413 to 450, and this one is going to be considered not impacted. And I'm going to explain what is the reason of these ones. I was checking the guideline, and I saw for industrial soils, the limit is 400 ppm. It means that if we have concentrations that are above of 400 ppm, it means that the soil is contaminated. But if we have concentrations that are below 400 ppm, 450 ppm, it means that the soil is not contaminated. Then I decided to establish this limit, and that's the reason because I put that one in a transparent color. Okay, but that one, it was the guideline that I was checking. Okay, every country, even every province, has a different guidelines, and the guidelines also depend the type of soil you are having. In this case, I'm assuming that I have industrial area, and for that industrial area the limit is 450, right? But for example, if the soil here is for a residential area, maybe the limit is going to be lower, right? Even if the area is an agricultural area like this one over here, the limit is going to be less. But in this case, I'm assuming for all this area the limit is 450. Now I'm going to edit the rest of the numbers. This one, the limit is going to be for 450 to 800, and this one is going to be low impacted. Now I'm going to fill all these ones, but I'm going to pass the video faster. That's it. I don't want also this one. I'm going to remove this one here. And I'm going to change the name of this one. That is going to be Muse River dataset. That's it. Now I'm going to change the font and I didn't add any title here. It's going to be legend. Okay, and this one is going to be with bold and 16 is good. Okay, and it's going to be at the center. For the subgroup is going to be bold. Okay, and also to the center. And for the items is going to be 12 bold. Okay, and also at the center. Then I'm going to put this one over here, and I'm going to apply some transparency to the background. Then select this one, transparency, something like that is good. And now the next step is just to export the image. Then I'm going to select this option, close, and I'm going to save here as a number 2. Save. The resolution and the dimensions is good. Save. Double click to open. It's going to be a different folder. Where I saved that one? I believe I saved in a different folder. Graduated map, let me check. This one. And that's the final result. As you can see, the quality of the map is really good. We can see the things really well. In the legend, we have everything specified, the limits and the concentrations, and I established different categories according to the concentrations. And that's it for the map. Now what I am going to show you, I'm going to take this one out from here, cut, and I'm going to paste in the proper folder. Is this one, paste over here. And now I am going to show you how you can reproduce the 3D model that I showed you at the beginning of the video. But that one is going to be something additional to this tutorial, okay? First, we have to install a plugin. Then go to plugins here. Make sure you have internet connection. The plugin that we are looking for is QGIS 23JS. QGIS 23 is this one over here. Then install plugin. Make sure you have this box checked, then close. And we have the tool over here. And also if you go to web, we have the tool over here. Okay, then let's go to open with this one here. Looks like we have to restart QGIS. Then I'm going to close this one. Make sure you save your project. Save and close. And let's go to open this one again. I restart the computer and also the QGIS, and I'm still having the same issue with the plugin. Looks like this plugin is not working with this version of QGIS. I'm going to show you what is this version. Help. We are using this version, and looks like with this version the plugin it's not compatible. Okay. Then what I am going to do is close this one, and I'm going to install the new version of QGIS. Then I can do from here, from the Geo RGB community website, because we have a tab where we have a lot of sources, and here we have QGIS. Then click, and this one is the last version, is 3.20.2, and I'm going to download this one and install this one. I'm going to pass the video faster. It's going to be this version, okay? Okay, I installed the new version. I'm still having the same problem. Now I have the new version, that is the 3.20.2. I'm still having the same problem. Then my conclusion is that I'm using a virtual machine on my main computer, and maybe there is a kind of incompatibility with the virtual machine with that plugin. Then what we are going to use is my main computer with the project I was working before. Is the same one, but the name of the layers are a little bit different. But I'm going to show you with that one, okay? Then I'm going to bring the project here to these windows. Okay, it's the same as the other one, but what I did here is for this layer, at the beginning I have this layer that is covering all the area. It's the same as this one here, okay? The same as this one, but what I did is cut this layer, and the result is this one. Okay, as you can see now, I'm going to take the satellite imagery to see the difference. This one and this one, okay? This one, it was the beginning, then I cut with the mask. The mask is this one, the limits, okay? What happened here, the limit is white color. Let me change for a different color, for a black, for example. Apply and OK. Now we can see the limits. Then I use this one, these limits, to cut the vectorial layer, and the result, it was this one over here. How I cut that one? With the vector clip, and then the input layer, in this case, is going to be this one, this layer over here, and the overlay is going to be the mask. Then you can save that one, and you are going to get the result, this layer over here. Then the next step is to run this one here. I'm going to bring over here. I would like to see the satellite imagery. Then I'm going to add this one here. At the moment, I'm going to take this one out. And that's what we saw at the beginning. Then you can move your 3D model as you want. And I'm going to show you what I did here to have this vision. Then go to a scene properties, and here I put these parameters, okay? For the vertical exaggeration, I put 0.2, okay? Because if you put something bigger, the exaggeration is going to be too much, okay? As you can see, even you can put a little bit less if you want. Apply and okay. And then I added, let's go to make this one smaller. Then I added this layer here to see the triangle interpolation. And for this layer, that is this one over here, we can see the properties here, okay? The properties I use for this layer, and it was this one, okay? For mode, relative to clipping layer, and that's it. And also we can see the properties of this one. Properties, the configuration I was using is this one, with this one to the maximum, and also with this one to the maximum. Okay, then I added the Muse River dataset, that is the samples, but it is in white color. And then you have the model over here. Okay, that's it for today. Thank you very much for watching this video, and see you on the next lesson.